session, we have Odie, Ben, and Mitch from Depop. Odie is a lead data scientist in trust and safety at Depop and the founder of Brushwork. He holds a PhD in machine learning. Ben is a senior data scientist at Depop, working in search team and specializing in ranking solution. Mitch is a senior ML scientist at Depop, having worked in searching and ranking team and now working in the recommendation team. They're going to enlighten us with their talk title, Optimizing Search and Discovery at Depop.
Hello, is this on? All right, thanks everyone. My name's Odie. So our talk is going to be split into two parts. So we're going to start with the future of diversity, an open letter from Depop, where I describe kind of the advancements in diversity and draw parallels with our recommendation systems at Depop. And then after that, my colleagues Mitch and Ben will come up and give their talk as well about optimizing search. So yeah, to start with, I'm Odie. Thanks in advance for listening to me speak about two of my favorite things, diversity and software. I'm a staff ML scientist at Depop, which is a second-hand marketplace for clothes, kind of like eBay, but for fashion. I wanted to share a bit about the way we think about diversity within our work and how it parallels the way we think about it within our team. And as we come together to talk about data science and its applications, we should celebrate the impacts all of our diversities have across our industry successes. So marketplaces like ours live and die by their machine learning. Every pre-loved item is a unique combination of brand, era, condition, location, so many facets, and we have tens and tens of millions of them. And as the Muppets taught us, every person is certainly unique. So this leads to an incredibly hard matching problem between people and items, because when something is sold, because we have unique one-of-one items, when something is sold, it's gone. And so maybe person A might have loved it, but person B has bought it, so we can't suggest it to person A anymore. So this is a bit of a challenge for us. And this is where marketplaces can teach us something useful about diversity. There is only so much utility in the populace. Even if people will like an item, that's no good. Only one person can buy it. We can't be everything to everybody, but we can be that perfect thing for each different individual. And this raises the utility of the whole marketplace. So the thesis of the marketplace is that diversity is a superpower. And that's something I hope resonates with everyone in this room. At every level of decision-making, from nodes within a neural network to comments on individual PRs to whole boardroom strategies, better decisions get made with diverse thoughts. I want to acknowledge the pluralism of thought that originates from diversity in all its stripes. So diversity of ethnicity, culture, class, neurodiversity, age, we've got all decorators. Someone wrote that software that my legacy bank is still using. So we could, yeah. But I think it's important to celebrate these and the 100 of other useful facets of diversity that make companies that build software better. We all know that, there's this stat that companies with more diverse boards make more money. Companies with more women on their boards have higher returns on equity, higher valuations, lower likelihood of shareholder dissent, just better. And I'm about to talk about how diversity has been profitable for us, but I want to acknowledge before we get into it that, of course, making money is only one capitalist way of measuring success. This should come behind ethics and human experience as a yardstick. However, they are much, much harder to measure, and whereas money is carefully recorded. So let's acknowledge that money is tangential to what we care about, hopefully correlated, and move forward. So back to measuring the power of diversity. Those of you who know Depop know that our recommendations are very personalized and finely tuned to help buyers find what they love, and they're really good. And there are these series of beautifully named metrics that are really important to the success of our recommendations. Diversity is chief among them. It measures how different the clothes are to each other in the set of items that you're recommending to make sure you're not recommending lots of versions of the same thing. Because, if you're going to recommend Nike trainers, you can't just recommend only Nike trainers. You have to recommend diverse enough Nike trainers. So diversity is the parameter that prevents that. The math says nice and non-obvious and includes something called a Frobenius norm, which I think is a really fun maths word. the diversity term can be optimized, but it's a pretty high diversity coefficient that's most profitable for us. I would like to think this plays out across all of our work experience. The first impression that you get is that the set of Nike trainers look great together. In the workplace, this is an early experience that working with and hiring people similar to you feels most comfortable. Have you noticed that people tend to hire people who are just slightly less good looking than them, maybe slightly shorter than them? But if you're measuring outcomes, you notice that the groups where there's productive discomfort shine. They don't get stuck in intellectual cul-de-sacs because straight from the ML definition, a diversified system contains more information and can better fit various environments. Not very catchy, but that's what it is. What this means is our businesses, where information and ideas reign supreme, expect to be rewarded for the diversity you bring and expect to profit from the diversity you're surrounded by. So another metric that we have that we look at is called serendipity. So serendipity is like the mathematical concept of the aha moment. It's balancing relevance with surprise, because it's nice enough to discover what you expect to discover, but like, how do you know you don't like this other thing? And that's where serendipity comes in. So being recommended milk in the grocery is highly relevant, but it's not very delightful. Being recommended that Nike trainer in a slightly different color won't make me excited, but maybe if I got a vintage high-top trainer with a paisley pattern similar to the Supreme Nike collab, will be more exciting. So serendipity relates to diversity in that both metrics measure how well the algorithm can introduce variety, but serendipity emphasizes the unexpected and beneficial impact of the recommendation. I think it's an excellent metric for team performance too. Diverse teams have high serendipity. Colleagues have ideas that surprise and delight you that you would never come up with. A group of people with similar life experiences are just less likely to come up with, ideas that will fit the breadth of all of your customers. And another metric we have is fairness. So fairness is a meaningful third metric to highlight here, and it's one that we think about for all of our ML products. Are we giving all sellers an equitable opportunity for their clothes to be seen and bought? Because you can't just promote some sellers. It has to be fair, and everybody needs to get an opportunity. So there are ethical considerations to the ML products that we use. The older ML that analyzes descriptions that the seller has written tend to be NLP models built from Wikipedia English. So this can have a range of kind of unexpected consequences. One is this might mean the models stand a better chance of understanding and indexing a more accurate representation of item if the item's description is written in kind of perfect, good English. So, for example, someone who's been, speaking English all their life, or middle-class English, it might not index an item so accurately if the description is written by someone whose English is influenced by their cultural background or ethnic background and upbringing. So our ML could make those less accurately indexed items less visible. We can correct for this with a semantic layer that abstracts understanding from the language, and we take care to monitor it. Correcting these unfairnesses across marketplaces is not only just, it's potentially profitable, as it makes more items more visible. So we profit more from fairness, because if we're showing everybody fairly, everybody has a chance to be bought from, and there's more profit for everyone. Within all of our teams and work, fairness is the metric we focus on and optimize for. It's foundational to all of our ethics, but focusing on this metric alone hasn't changed the industry as quickly as we'd hoped. We still have a leaky funnel, the poor relative of the leaky bucket, where we have diverse early career cohorts, but the diversity among staff engineers is usually lacking. So I guess this speech is a plea for us in this room to help heal the leaky funnel by optimizing for diversity with fairness as a satisfying metric, but leading with serendipity, novelty, engagement, and all the other delightful metrics I spared you the descriptions of. I'm pleased with the direction the conversation is shifting in, and I hope this is the right moment to push for not aiming for the norm. We should promote and celebrate our diversity and all the serendipity that brings with it. We know it will make us more ethical, more profitable, more human experience-led, and hopefully have careers full of delight. Yeah, that's it for me. Right, I'll now be passing the mic to my colleagues to continue the talk. Does anyone have any questions before I do that? Or comments? Or awesome.
All right, thanks, Odie. So second half of the talk is, I'm going to lead the first bit and then Ben's going to pick up. And we're going to be talking about a fairly high-level topic, but it's optimizing for release frequency at Depop. And we think this is quite an important problem that kind of applies to any machine learning problem. So we're going to talk specific to the problem of search. So I'm just going to give a quick intro on that. But then we're going to talk about a lot of the lessons we've learned over the last 2 years from implementing this system and what we try to now do in like other machine learning problems at Depop. So first of all, you may or may not have heard of learn to rank. It's a little bit of a niche topic. But learn to rank is essentially the problem of if you have a search engine, you get some text matches back. Say someone searches for a pair of shoes, you might get 1,000 items, say, or maybe millions in the case of Depop. But then, you show them 100 items. They look through them. They maybe look at one and they buy one. And what you want to do is make a machine learning system that over time tries to put the items that are going to get bought or viewed towards the top. And then people will stay more engaged. If someone has to scroll through 1,000 items, they're probably going to leave the platform and go to Vinted or eBay. So yeah, what we do is we have historical search data where we have like an ID per search, what someone searched for, the items that we showed them, and then we give it like a relevant score based on what kind of interaction they had. And then we have a bunch of features. And so essentially what happens is we get a machine learning model that learns, given these features, try and predict a score, which will be a float. And if you order those scores for a search, you should get the same order as the relevant scores, i.e. the highest relevant item should have the highest predicted score. But that's just to give you a bit of concrete context of what we've been working on. We're not really going to talk about the specifics of this problem, but hopefully it gives something to anchor. So the specific thing we're going to be talking about is about optimizing for release frequency. And you might say like that maybe doesn't seem like the most important thing for a machine learning problem. Maybe for like engineers feel like they've got to release features frequently, maybe ML a little bit disconnected, but we actually argue that essentially what you do is at the beginning of this orange line, you come up with a new project that you want to launch at Depop. So you say, let's start doing learn to rank in the search engine. Let's see if we can improve it. And you put a POC together in a notebook, you launch something, and it's great, and it increases purchases by some percentage. And what happens is everyone else at the business says, that's great. We've got now 3 people working on this problem. Do it again. And then that happens. So essentially the expectation is this orange line, that per month or quarter or year, you're giving the same impact every time. Every month or every quarter, you're giving some percentage increase in purchases. But the issue is that it gets harder as you go along. Your first one is maybe like 3 or 4 features. And your second one, maybe you get the same impact with a similar number of features. But at some time, it gets harder. You have to start doing smarter things with your model. You have to start putting in hundreds of features or experimenting with hundreds or thousands of features to get the 3 or 4 that are good. And so what we'd argue is in order to maintain that impact per month, you need to increase, at some point, you get this inflection point where the number of releases you need to do per month starts to shoot up. And so really what we're going to be talking about is like what issues do you encounter when you try and do that? And really this is the issue we think is that the POCs, the stuff you do at the beginning in your notebooks or whatever it is, can only get you so far. And as soon as you hit that inflection point, that's where you run into issues. You start tripping over yourself. You've got tech debt. You've got 3 or 4 machine learning scientists working in parallel. And how do you share the latest bit of processing that someone's doing on the data? Or how do you share the latest thing before it's been rolled out? And these are top-level graphics, but you've probably seen this like ML cycle before where you come up with an idea, you evaluate it, and you probably jump between these two for a while. At some point you deploy it, you monitor it, and you test it. And this is happening, multiple machine learning scientists in parallel are doing this. You've got engineers coming in at various points. And so really the idea is going to be that you want to make this as smooth as possible. And actually, I think the core of the idea is that for the model that's in production, you should be able to do this whole cycle with very little effort, without adding anything new. So if you just wanted to update your model with like some recent data from last month, you should be able to almost just like click a button and have this happen. And if you have to go and do manual steps, if you have to go and edit a bit of code in several places, etc., then that's where you're going to really slow down and really struggle to keep that high frequency that you need. So we've got like 3 main themes that we think we've learned over time. So the first one is rapid iteration. And as I said, it's about getting through that cycle as quickly as possible. So each step on that loop should be quick, should be automated. You know, like context switching is one of these buzzwords people say, but it does have a big impact. You know, if in the morning you have to edit a few configs, release a PR, press a button, wait half a day for some data to load, etc., that actually does take up a lot of mental energy. So rapid iteration isn't just about how long it takes to run, it's also how many steps are involved in it for the person running it. So the first kind of example of what we've done is implementing DAGs for data generation. And so, yeah, essentially I showed this table at the beginning for our search data. And the idea is that every day we should have something automatically running which will make the features that are in our champion model for this historical data ready to train a model on automatically. So it's there, everyone in the team can use it. No one has to go away and say, regenerate this data for this latest day or months or whatever. And then really the magic comes in at the bottom here, which is like, I've come up with some new features that I want to test. So I write code just for this bit, and I add just a column on the end. And so we do this, we get the historical data, do some processing, put the interactions on it, put the features on it, and put that all into a table, and that's happening automatically. So that was our first big win as a team to kind of help us increase that frequency. And just to mention here, Tecton, which you may or may not have heard of, this is our feature store, so there should actually be one here as well. It seems to have disappeared. But essentially, this is a feature store that just means that if we write some PySpark to generate some new features, when we're ready to integrate it into that DAG, we just like change a flag and merge a PR, and then it's in our DAG. So if those new set of features are ready to be merged, we submit that PR, they get moved into champion features, the rest of the team then have that data. So that means that first step in data generation is quick and doesn't slow us down. The second one is, again, something that I think probably everyone knows should be implemented, but maybe isn't, is like robust ML pipelines. And again, this is about, you've made the new PySpark for your new feature in Tecton, and you want to test it, and maybe you've put like 100 features in there. You want to try several variants that you've given, whatever these versions mean, but you want to test them all out. Maybe you're doing some hyperparameter tuning as well, or whatever else it is. But when you're ready to do that, you've done the hard bit of writing the code. You want to just run the experiment. You want it all logged, and you don't want to then write up an experimental report. You don't want to sift through data and different things and make all these other graphs. So having a robust pipeline where you can essentially just edit a config and say, like, here are the new set of features, here are what I'm defining. So you'd put a config for your data version that would have this new set of features, and then you'd make a config for each training version that will have different parameters or different sets of features that are available or whatever it might be. And then you just hit go. And we use Databricks as a package they use called DBX, which I think is now depreciated, but there's a new version of it. I can't remember what it's called. But essentially, from your terminal, you'll be able to just like merge it on the CLI, and then these jobs will launch. So we'll get those features will be added to that data DAG that we've got for the dates that are defined. It will then train several models as you've defined, and it will evaluate several models as you've defined, including on like whatever is merged to champion whatever is powering the app. And then you'll get all your nice reports as well. And so those first two things, iterating to create new data and evaluating it. Now, actually, the only thing you really need to spend your time on is the bit that we do in Tecton, which is like write some new PySpark for some new feature idea that you have, and everything else kind of happens automatically. You submit a couple of commands and maybe edit a config, and that's it. And so that's been really key for us in terms of increasing the frequency that we can release. And then the third thing on rapid iteration, before I pass over to Ben, is about deployment. And we actually think that deployment is one that's probably often ignored. Like, you get to the point of you've got a model working offline, and then probably you do something a little bit hacky to try and get it out there. Maybe not hacky, but maybe it's good, but like the process is maybe not as robust as it could be, and maybe not automated as much as it could be. And so again, something we've implemented here is using Jenkins and like automatic PRs. And so what you'll do is you've made this model, there's some new data processing, there's some new features in there. And so you essentially maybe edit your inference script, which will just point to some of these new stuff, bits that you've put in your DAG. This will build an image along with the model that you've trained, the artifact that's been logged somewhere, and it will update a SageMaker endpoint and make it available for the backend. And then the second half of that is essentially what will happen is the engineers working on the backend that want to serve this in the app. So the dotted line is what's happening in the Depop app. Someone does a search, we get the features for all the products. We pass it on to our SageMaker instance to process those features, make the predictions, and pass back the order we think the item should be in. Essentially, all they have to do is change a flag, and it will start pointing at this new endpoint. It will start getting the correct new features, which means that they change a flag and they set up an A/B test. So that whole cycle then is really quick to get through. And essentially, as an ML scientist, the thing that you can focus on is making new features or editing the model or whatever it is. But yeah, so that will happen. And then the last bit is really as well, often really ignored, is about like alerts and logging and monitoring. And this is usually like someone slaps something together and it's like a dashboard somewhere with some plots. Maybe it's manually rerun, or someone says, is something working? Are we sure this A/B test looks a bit weird? And then you go into a notebook and do a bunch of manual data analysis. And so we've realized as well that really ironing that process out has really helped, which means that automatically all those logs are done, all the common processing is done, alerts are set up so that we can be proactive, and then every dashboard you could want is there. So if someone is trying to like introduce doubt, is it really doing what it should be? You can kind of just point them at the dashboard and say, like, here it is, like it is doing what we expect. And so this is like 3 examples of rapid iteration where really concentrating on automation and like minimal intervention from the ML scientist means that you can focus on what value you can add to the machine learning model. And I'm now going to pass you over to Ben, who's going to talk about a couple of other themes.
Thanks, Mitch. Yeah, so I think early on in our cycle, we kind of started to recognize that some patterns started to repeat themselves over and over again. And one of those was that we kind of needed to reproduce old results to kind of validate what we were seeing happening in the past against what we were seeing happening right now. And at the very beginning, this was really slow and really painful. We were living in a kind of notebook world, and historically, notebooks are very hard to version control. So as you can imagine, that process is quite tough. But as we moved on to more automation, as Mitch alluded to, we kind of pulled kind of data and into DAGs, which basically allowed us to automate a lot of processes and allowed us to start to version control at least our data to help us basically make recreating historical situations much, much faster. So here is a kind of wide overview of how our kind of a DAG is structured. So Mitch kind of showed you that representation of our data at the very beginning. This is kind of how it's created in the DAG broken down. So what we did first is we partitioned the DAG into different steps, where each partition was kind of a logical process, distinct in itself, had its own constraints, its own requirements. This kind of naturally allows you to allocate the appropriate resource for each partition. And each partition kind of has its own sort of, how do you say, like update throughput. So on the left-hand side, starting on the left, we have our search spine. So what this really represents is kind of like a quasi-primary key for our search data. So these are all the things that contain like search ID, product ID, search timestamp. This is like important for us to joining onto our other data events in our data lake. This basically is quite stable, so it doesn't tend to iterate too often. The next step is then correct in time features. So these are where we start to draw in things like the attributes of a product, or like the text, for example. And as Mitch mentioned, this is largely powered by Tekton, our feature store, which kind of gives us out-of-the-box correct-in-time features, which has been very valuable for us in order to make sure our offline data set kind of corresponds with what we'll see online. This is kind of a consequence of users updating listings quite frequently. So you can imagine a product that's been updated n number of times since it was first posted for listing. That data gets quite large, so it's actually quite a difficult problem to figure out what that the text was at a particular point in time for quite a large inventory. So that's kind of partitioned into its own section, and once you have that joined, you then have our third and final partition, which is kind of those features you can only calculate at the point of inference time. So once you've got what the query is and you've got what the product is, you can kind of then do things, for example, query text kind of comparisons. So this is also like a process that's calculated offline. And each of these partitions have their own versions, and you can kind of see like from the version numbers the kind of frequency with which they're updated. So what we were noticing basically was that, for example, inference time features could contain some bugs, or it could be like an upstream data source was kind of broken in some way, which meant we needed to regenerate this data. What this allowed us to do was to very quickly backfill just one partition of the data rather than the entire thing, which was slow and just compute inefficient. But this has also basically meant that we can reproduce data for our old models very, very quickly. And what is cool is that you can now kind of tie these versions to GitHub, like commits on the repo where all this data ETL code lives. And you can also tie versions of like services that feed into this data to these versions. So in Tekton, you have this concept of like a feature service that has to be versioned. So now we know like the actual data is versioned to all of the services that feed into it as well, which really gives us like one config, which is a single source of truth for how to recreate this data. On the other side, so once we have the data, we also have like a historical store of experiments. So when you run an experiment, you kind of basically want to keep track of what your results were. It's really important because if you don't know what your results were previously, it's really hard to make decisions in the future. And so we often use MLflow as our primary kind of model registry for now, and we store all of our results here. We store like the config file. You can see the config.yaml near the bottom, the model binary itself, and some like metadata. Actual plots and graphs also live inside the MLflow server. And yeah, so this is just a reference point that we can go to. So this will be tied to every released re-ranker, so we know what the results were and what to expect. And basically, we can make any kind of historical comparison, or draw in this model and reload it, and then apply a new inference on new data with the old model, which allows us to do these comparisons relatively quickly. So the second part was kind of measurement. So I think this was also a bit tricky because often we would find like strange results online, and this basically triggered this cascading debugging effort that became very difficult to kind of untie. So measurement is really important because without it, you basically have to assume everything's a culprit of a bug, which is not a fun way to begin a process. So with the testing, so first of all, we kind of rely on Optimising for our A/B testing, and I think this so far has worked out very well for us. It allows us to launch tests with relative ease. So in our backend, we effectively have like a config that controls what variants get sent to which people in test groups, and this has been really, really useful. I think if you have a complicated process for launching A/B tests, you basically have to concede that that's like a definitive period of time that you have to devote to every release, which just increases the lead time for all these releases. So this is, by eliminating all that time, it's just helped increase the throughput. And on the monitoring side, we use Arise for feature monitoring and model performance monitoring all online. And this has been invaluable. Like, if there have been issues in production, this has helped us flag them early before kind of leading with kind of lead lag metrics that might indicate it like a day late. But also, for example, if we were to see really strange results in Optimising that we weren't expecting, like I was alluding to before, this now allows us to kind of eliminate sections of the code as sources of the problem and really drill down to where the issue could be, which helps us speed up debugging to no end. And lastly, in the ranking world, we have this I suppose in the ML world, but this is particularly tricky in ranking, is this concept of online versus offline. Like how well do your results in your experimentation phase match to what you're actually seeing when you try to deploy the model? It's because in your experimentation phase, you kind of construct a representation of what you believe is a true representation online, but it's all too easy for like human bias or judgment to get put into that experimentation phase, which can be problematic. So I think for our end, we kind of we used classical NDCG as our primary metric for experimentation. For those who aren't too familiar with NDCG, it's basically a metric that's sensitive to given a search and like the results of the search, the positions that somebody interacts with the results are recorded, and then you apply a re-ranker to those results. And the idea is that NDCG will be higher when those interactions are ranked higher. So if somebody interacted with something at rank 5, and then we re-rank the results and that kind of product got moved up to rank 2, then NDCG would have a preference for that. And NDCG specifically has this kind of log reduction factor, so it prioritizes being sensitive to things moved near the top of the ranking. So like if you move something from rank 50 to rank 20, it doesn't care as much. So basically what we kind of figured out quite early is that we need a criteria for releasing an A/B test. And this criteria came as like a threshold for NDCG improvement. The problem space is that if you make the threshold too low, then you experiment you create more experiments, more releases, but you also those releases fail more and more in the A/B test. And because an A/B test takes like a finite amount of time, you lose the time you could have had to launch an actual successful test. So your actual impact or release, technically you have like a release to production rate is lower because you have all these failed tests. But if it's too high, then your experimentation phase takes forever as you try to continue to add features and optimize until you hit that threshold that you want. So again, you are wasting time you could have been testing, and your release rate is really low. So there is a middle ground you have to find, but also that threshold, it kind of has to be dynamic as well, because as you improve, you kind of get diminishing returns. So there's a bit of dynamic play. So it always has to be. You always have to be figuring out what that threshold should be. I think in addition, though, there is a human element to the judgment of whether you should release an A/B test. And that's simply because all metrics have their limitations. They all have failure modes. I think there's 2 primary failure modes. It's either sensitive to things you don't care about or insensitive to things you do care about. And you basically have to have a little bit of critical analysis on what your metric is actually doing. So NDCG, for example, I think it has it's not so clear, but it can be parameterized. So, for example, depending on the package you're using, it can be implemented slightly differently. And therein lies a way of having human bias introduced into the metric. So, for example, the steepness of the log factor kind of denotes how much you care about the rank positions at the top, or the gain function, for example, can be switched. And so you have to know, like, yeah, your metrics may not be perfect, but they're a good guide. But then at the end of the day, you should also try to like just visually look at your rank results to see if they make sense, to include that human judgment. Because there are certain scenarios where a low NDCG value can actually not reflect a potentially very positive A/B test launch. A typical example is when your new re-ranker variant is actually going to increase recall a lot, but because of something called presentation bias, where the users are not exposed to those items, offline is kind of had no visibility on this at all. So to illustrate that with an example, say I wanted to like optimize so that the results were personalized for sizes. So in the offline world, the user has only seen so many of these listings, but they probably stopped scrolling at the point where all of these relevant items are at the bottom. So the model has, the evaluation script has no visibility on this at all. But as soon as you deploy it to production, all of these really relevant items that were, previously ranked at like 2,000 suddenly go up to like rank 12, and the user's really happy. But this was not something you observed offline. So sometimes it's also like there's room for kind of conviction-led release criteria. That is it. Thank you very much. And we're also hiring if anyone wants to visit our careers page. But was there any questions? Oh, sorry, yeah.
So when you have your metrics, what percentage of the time when you run an experiment is it successful? That's one question. And then the other one is, do you see models degrading over time, or you release so quickly that you probably don't see it, you don't have a model in production for long?
Yes, it's two really good questions. So, to your second question, I think so far we've not seen too much of a degrade in our model performance over time, even though it's something that we've been very conscious of and we're constantly evaluating on. So I think it's something we know comes into play maybe with more as your re-ranking gets more and more complex. So I think I think automated releases, like retraining and releases, is something on our roadmap, because it is something that affects when the signal is like seasonal or trending, for example. But so far we've noticed it's been like quite long periods and you can get away. Oh, do you have a...
Just going to add, we also mentioned it, but on those A/B tests, so those will run for like a week or two, and we'll see if it beats the previous model. But we'll also have like holdouts that usually last like a quarter. So something we have noticed is that like a model in like Q1 will stay in the Q1 model, and we'll still see at the end of a quarter the combined effect of all our A/B tests. And usually it is a bit different because also like there are long-term effects that you can't counter in 2 weeks. But we haven't seen anything, as Ben was saying, really drastic over those quarterly periods.
Yeah, so could you remind me your first question again?
It was about an idea of, because you have you mentioned a threshold on
Yep.
your metric.
So you mentioned when you're doing model experimentation, you have a threshold in your metric before you put it to experiment in the real life.
Yeah.
And I'm just wondering how much of the time do you actually get positive results in the experiment?
I see, yeah. So far, we've been quite lucky and gotten quite a lot of positive results. I'd say our success rate has been quite high. I mean, that's a factor of there being low-hanging fruit at the beginning, and also maybe being a bit more conservative, potentially. But yeah, I think it really is a matter of trading off like more and more experimentation versus quicker release rate. And so far, I guess we have been biased towards having less A/B tests and more success.
And one other thing we noticed is like there have been surprising results, and they can go either way, where like the impact will be bigger. But typically, we'll have like some metric will correspond to some percentage in sales increase or something. But occasionally, it will be like twice as much or half as much. And those tend to be features that are a little bit unusual because there are, and I think Ben kind of mentioned the online-offline skew, there's a lot of like presentation bias in historical because we are sorting the searches for the items that we showed to that user. When we put a new model in, it's actually getting entirely new items that we have no way of really evaluating offline. And so that's when the surprising things come in. And sometimes that means that we're accidentally showing something that people love and they buy loads more stuff. And occasionally it's like, they hate this. It's not good, or it's flat, or it's negative even. But yeah, as Ben said, our success rate's been quite high so far. So most of those are the typical ones where you get a small bump and a small bump.
Thank you for the questions. Thank you.